Laplace transform of derivative. Given the formulas of Laplace transform is the integrations of e power of negative st multiplied with ft dt. The function here can be also in terms of the derivative. If you have f prime t, which is the first level derivative, substituting this into the formula here, you will get this. In order for you to integrate these functions, you know that it is multiplications of two functions of t. You will need to use the integrations by parts to solve it. To solve it, let u equals to e power of st, while the remaining will be ft dt, which is the dv. Differentiate the u, you obtain this, and integrate this, you get v. Substitute this value into the equations for the integrations by part. U v v du. Solve the functions here, you will get this. This is in fact the original equations of the Laplace transform, which can be presented in the notations of Laplace transform of ft. As for this function here, substituting the upper boundary to be minus with the lower boundary, e power of infinity will give you 0. That gives you 0 minus f in the functions of 0. That gives you this solution. From the derivation here, you know that the formulas of Laplace transform of derivative can be represented in this manner or this manner, which is s Laplace transform of ft minus f0. The same principle apply for the second level of derivatives. Based on the formulas of Laplace transform, this is the formula. If your ft is in fact the second level differentiations of t, that means you will substitute this into the formula. You will need to integrate these functions. These functions consist of two functions of t which are multiplied together. To integrate this, you will need to use the principles of integrating by parts by using this formula. Let u equals to e power of st, while the remaining will be the dv. Having the u, differentiate the u to obtain du in the functions of dt, and having the dv, integrate it, you get v. Substitute the relevant value into the formulas of integrating by parts, you will obtain this. U v v du. And these functions, if it is being rewrite, you will become this. While considering the boundary conditions, substitute the upper boundary into the functions and minus with the lower boundary substitutions. E power of infinity will give you 0, and e power of 0 will give you 1. When you substitute the lower boundary, you are looking at the f prime 0. When you rewrite these integrations, it will be this, and this happens to be the functions for the first derivative. That means you can represent this in the form of this. And if you substitute the formulas of the first derivative into the functions, you obtain the equation here. These equations can also be represented here. With that, the Laplace transform of derivative can be represented by two equations. The first equation is for the first derivative, and the second equation here is for the second derivative. These two equations will be useful for you to solve the following Laplace transform example.